This is Module 1, Lesson 1, Numerical Expressions. After this lesson, you need to be able to write numerical expressions for verbal expressions, and you need to be able to evaluate numerical expressions. Let's learn writing numerical expressions. So first, a numerical expression is a mathematical phrase that contains only numbers or mathematical operations. So for example, 6 plus 2 divided by 1 is a numerical expression. There are only numbers and those mathematical operations. In some numerical expressions, they contain multiplication, and multiplication is the tricky one because it can be represented in several different ways. So these include a raised dot or parentheses. So here are a couple ways you could represent the same product of 2 and 3. So first one here, we could represent 2 times 3 with that dot. Here, we could say 2 and then parentheses 3. That still means multiplication. There's now a hidden multiplication symbol. We could switch what's in the parentheses. Again, there's still that hidden multiplication in between. And then finally, we could put both of them in parentheses and another hidden multiplication. So there are a few ways you could see multiplication. If there's not a symbol there, it's indicating that you need to multiply. Example 1. Translate a verbal expression. So translate 1 plus 8 divided by 3 into a numerical expression. This is where our goal of writing a numerical expression from a verbal expression comes in. So here's our verbal expression. We're going to change it into numbers and or mathematical operations. So I just take the sentence and write it in math. So 1 is the number 1 plus sign, 8, number 8, divided by that symbol, 3, the number 3. So squishing it all together, our translation would be 1 plus 8 divided by 3. Exactly what it said, we just wrote it, only with numbers and symbols. Check your understanding. Translate the verbal expression into a numerical expression. Pause the video and write it now. Check. Here we have 7. I chose to put the multiplication symbol, then 15 minus 2 times 9. Example 2. Translate a verbal expression with grouping symbols. Translate the sum of 5 and 9 divided by 2 into a numerical expression. So here, they kind of marked it out for us, but if you see the sum of, and then it gives you 2 parts or 3 parts, that indicates that that part is in parentheses. So the sum of 5 and 9, the sum of indicates the parentheses, and then 5 and 9 is what's inside. So this is the sum of 5 and 9. Then it's divided by 2. So 5 plus 9 in parentheses divided by 2, squished all together, 5 plus 9 in the numerator, and then 2 in the denominator. If you just wrote it sideways, where it was the parentheses and then divided by 2 squished together, that works too. Example 3. Write a numerical expression. Our real context here is bowling. A person's handicap in bowling is usually found by subtracting the person's average from 200, multiplying it by 2, and dividing by 3. Marley's bowling average is 170. Write a numerical expression for Marley's handicap in bowling. So here they broke it into steps based on what was said in the problem. So the first step is to subtract their average from 200. So if Marley's average is 170, we're going to subtract that from 200. So 200 minus 170. Then we're going to take that and multiply it by 2. Notice in the next step, they put the 200 minus 170 in parentheses, indicating that should have been done first. Finally, dividing the result by 3, so here they made a fraction all over 3. So if we want to calculate that out, 200 minus 170 is 30. 30 times 2 is 60. Then 60 divided by 3 is 20. So Marley's handicap would be 20. Check your understanding of writing a numerical expression. Read through the context, then choose which numerical expression correctly converts 37 degrees Celsius to Fahrenheit. Pause the video and figure it out now. Check your answer. So to convert from Celsius to Fahrenheit, first we're going to multiply by 9, then divide by 5, then add 32. So let's figure out which of these shows that. Multiply by 9 first, so take your temperature multiplied by 9. All of these on the top say multiply by 9, except that last one, that's multiply by 5. Then we want to divide by 5. So if we're looking, multiply the top by 9, divide by 5. That one's good still. Ooh, this one says divide by 5 and 32. Not that one. This one says divide by 5. Finally, add 32. Add 32 or multiply by 32. We want to add. So A should be our correct answer. We multiplied by 9, then divide that whole thing by 5, finally add 32. Let's learn evaluating numerical expressions. An expression of the form x with n as the exponent is read x to the nth power. The word power can also refer to the expression, to the value, or the exponent of the expression. When n is a positive integer, so a positive counting number, the exponent indicates the number of times a number is multiplied by itself. In a power, the base is the number being multiplied by itself. When no exponent is shown, it is understood to be 1. So for example, 7 is equal to 7 to the 1 power. To evaluate an expression means to find its value. If a numerical expression contains more than one operation, then the rule that lets you know which operation to perform is called order of operations. Remind yourself real quick the order of operations. So first, step 1, evaluate anything inside grouping symbols. Not just parentheses, you might see brackets or other types of symbols. They all mean the same thing. Second, once your grouping symbols are done, then you're doing all your powers or your exponents. Third, multiply and or divide. This is the same step. You need to do it from left to right. So multiplication does not necessarily come before division. Finally, adding and subtracting, again from left to right. And just like multiplication and division, they're the same step. So adding does not necessarily come before subtracting. You go left to right. Example 4, evaluate expressions. So evaluate each expression. In part A, we have 2 to the 4th power. We can see they wrote 2 to the 4th power as 2 times 2 times 2 times 2. They took that base of 2 and used it as a factor 4 times. So 2 to the 4th power means that it's 2 multiplied by itself 4 times. To evaluate, we just calculate its value. So 2 times 2 is 4, times 2 is 8, times 2 is 16. The same process is being used in part B. 4 to the 5th power is 4 used as a factor 5 times. So 4 times 4 times 4 times 4 times 4. Multiply that out, we get 1024. Example 5. Order of operations. Evaluate 20 minus 7 plus 8 to the second power minus 7 times 11. In this example, they already have everything written out for us in terms of our solution. What we need to do is identify what happened to go from one step to the next. My recommendation to do this is to figure out what has changed from one line to the next. Let's look through the first line, figure out what's missing. So first I have 20 minus 7 plus 8 to the second power minus 7 times 11 equals 20 minus 7 plus 64 minus 7 times 11. This might look a little weird. This part right here, and I'm putting parentheses just to show you, is the same as this part over here. So we're really just going to be focusing on this side here. So the first thing they did, if you notice, that 8 to the second power is now 64. So they evaluated our exponent of 8 to the second power. 8 times 8 is 64. Then it tells us they multiplied 7 and 11, which is right there. 7 times 11 is 77. It had that minus sign out front here, so it stayed. Next, what's changed? The 77 is still there, 64 is still there. They must have subtracted 7 from 20. 20 minus 7 is 13. Now, we're checking again. That 77 at the end is still there. Here they must have added 13 and 64. And then finally, they gave us our step already. We're subtracting 77 minus 7 is 0. Let's go through real quick and note how order of operations was used here. So first, we did our exponents. So there were no parentheses, so that was first the way it should have been. Next, we should have multiplied or divided. So if we look, they said they multiplied, that's what they did. Then we should have been adding and subtracting from left to right. So they took this subtract first and did it first. The rest stayed the same. Then they added next to get that 77. So again, that was the next one to the left. Finally, now they subtracted at the end. So here we went subtract, add, subtract. They're the same step, we just do them from left to right. Example 6. Write and evaluate a numerical expression. Our real context is an arcade. Melly is playing a bowling game at an arcade. She rolls 2 balls into the 30-point hole, 4 balls into the 20-point hole, and 3 balls into the 50-point hole. Write and evaluate an expression to find Melly's total score. Part A. Complete the table to write an expression for Melly's total score. So to find Melly's total score, find the number of points scored from each hole and add their products. So here they broke it down into a couple parts. We're going to combine the 30-point scores, then the 20-point scores, then the 50-point scores. Finally, we'll add them all together. So 2 balls into the 30-point hole would mean we have to multiply 2 times 30. If there were 4 rolled into the 20-point hole, then we would have to do 4 times 20. Finally, we have 3 that went into the 50-point hole, so 3 times 50. Now, we need to evaluate our expression so we can figure out how many points she scored. So first, we're going to multiply all of our things going from left to right. So 2 times 30 is 60, 4 times 20 is 80, 3 times 50 is 150. Now we can add, going from left to right, 60 plus 80 is 140, plus 150 brings us to 290. So Melly scored 290 points. This is a good example of why you're doing order of operations a certain way. If we were to just do everything from left to right, we would have 2 times 30, which is 60, plus 4, which is 64, times 20, which is 1,280. Definitely not the right scores. In this context, it makes sense to multiply the number of points by how many times she got that first. Then add those things together. It follows order of operations. Check your understanding of writing and evaluating expressions. Read through the situation, then determine which expressions represent Ika's bill. Select all that apply. After that, how much money does Ika owe the technician? Pause the video now and complete the problem. Check your answers. I'm going to start with part B real quick. Ika's going to owe the technician $175. Let's figure out how to get that. So first, the technician charges a flat fee of $50. That means there's going to be $50 no matter what, plus $25 times, you see that word per, that means times the number of hours. So on Monday he worked for 2 hours, on Tuesday he worked for 3 hours. So we should see the 51 time. So if I look through, there's 51 time, there's 51 time, there's 51 time. That says 25 one time, so not E. There's not even a 50 in that one at all. Then plus 25 times the number of hours. So it was 25 times 2 hours on Monday and 25 times 3 hours on Tuesday. So there's our 25 and 2 and our 25 and 3. So A works. What about answer B? Here it's saying 25 for 2 and 3. Well, if we think about how many hours the technician worked in total, 2 on Monday and 3 on Tuesday, if Ika wanted to simplify, they could just combine the hours together. So 2 and 3 together, then multiply that by 25. B also works. If they just combine 2 and 3 together, they get 5. So the technician worked 5 hours at $25 per hour. D also works. Then if we calculate out any of those, we can see the technician is owed $175. The last one here is the easiest. Example 7, expressions with grouping symbols. When one or more grouping symbols are used, evaluate within the innermost grouping symbols first. Evaluate each expression. So part A, we're given a fairly complicated looking expression. The quantity 4 plus 5 to the second power, all divided by 3 times 7 minus 4. So first we're going to evaluate what's inside parentheses. So 4 plus 5 is 9, 7 minus 4 is 3, which is what they got there and there. Next, we're going to evaluate the numerator. So 9 to the second power, 9 times 9 is 81. The next step is going to be multiplication and division. If you come across a fraction, before you can do the division that is the fraction, you need to be able to simplify the numerator and the denominator as completely as possible. So here, because we still have multiplication in the denominator, that needs to be done first. So multiplying 3 times 3 gives us 9. Now that our fraction, even though it's an improper fraction, now that it looks more like a normal fraction, we can treat the fraction as division. So 81 divided by 9 is 9. Part B, we're given another example. This time we have some brackets and some parentheses. So first we're going to evaluate our innermost parentheses. So we need to simplify this first because these parentheses are inside. Here's our inside parentheses. and then these are our outside parentheses. So we're going to evaluate the inner ones first. 3 minus 2 is 1. From there, we can keep working our way in. So we still have another grouping symbol, this time brackets, and inside those brackets, we have 1 to the second power. So I do need to do that first before I can add. So I'm following order of operations even if it's within grouping symbols. 1 to the second power is 1. Now I can add what's in those brackets. 10 plus 1 is 11. Once you've simplified everything in the grouping symbols, you can get rid of the grouping symbol. Here, they just left it. So we have 15 minus 11 plus 6. Now, order of operations says left to right for add and subtract. So 15 minus 11 is 4. Finally, 4 plus 6 is 10. Check your understanding with order of operations. Evaluate 2 to the third power minus 5, all divided by 15 plus 9. Pause the video and calculate it now. Check your answer. You should have got 1/8, 1 over 8. If we do the top, we get 2 to the third power, which is 8, minus 5 is 3, so 3 on the top, and then divided by 15 plus 9. So 15 plus 9 is 24. The fraction of 3 over 24 would then reduce down to 1/8. So if you got 3 over 24, you did it correctly. The better, simple answer would be 1/8. You can still divide the top and the bottom by 3.